Okay. Okay, good afternoon, everyone. Thank you so much for joining us on our webinar today. We're still waiting for more people to join, but I think it's best if we start now so we don't keep everyone else who was punctual waiting. My name is Busola, and I am the Director of Research at Versa Research. On this call is my colleague Mayowa, who's an analyst at Versa. Versa Research is a data research and consulting company. We're focused on building scalable and sustainable businesses. We are industry experts in product, market, and consumer research. Today we will be Today we will be hosting a masterclass on big data analysis, the applications, definitions, opportunities, advantages, and processes. We will speak for about 45 minutes, then we will open up the floor to Q&As. As this is a masterclass, we will also allow for some case studies at the end where a couple of people in the audience can share the kind of data they currently collect or they currently have, and we can brainstorm how you can derive business insights or business intelligence with that data. So you can start thinking about it, and if you would like, at the end of towards the end of the masterclass, you can share with us the type of data that you have, and we can share some ways you can derive insights from this data. So I think we can get straight into the masterclass. Please note that this masterclass is being recorded. Towards the end, if you prefer for confidentiality reasons to stop the recording when we're talking about your case studies, that's perfectly fine. Please just put a note in the chat box and Mayowa will work on that. And as we're going through the masterclass and the content, if you have any questions, please also make a note in the chat box as it's being manned by Mayowa. Okay, so let's get into it. So, what do you think all of these retailers have in common? They all have loyalty programs with their customers. These retailers incentivize their customers so as to attract new customers and or retain their existing customers. They give incentives such as rewards and discounts to encourage repeat businesses. What many customers and some retailers might not know is that when you sign up for these loyalty programs, you provide your basic personal information. So information such as your name, your address, your telephone number, your email address. But every time you purchase at these retailers and you present this loyalty card or you use the app on your phone, the loyalty card app on your phone, information such as what you are buying, the way you are paying, and in some cases, your payment information is collected. So let's talk about an example, the American retailer Target. Target has been able to use data, this kind of data, purchase pattern data from their loyalty program customers to figure out exactly what their customers like, what they need, how to attract them to keep buying from the company. The first step that Target took was to look for patterns in their customers' past buying behavior. In particular, they looked at customers who had a baby registry at Target, and they looked at some of their past buying behavior based on their loyalty data. With this, Target was able to outline purchases that pregnant women make at different stages of their pregnancy. So for example, they found out that in the second trimester of a pregnancy, pregnant women are more likely to buy lotions. So they increase the quantity of lotion, body lotion that they purchase. They use this pattern to predict and to forecast the stages of a loyalty customer's pregnancy. So based on their current purchases, they were able to see at what stage in your pregnancy their loyalty customers were. With this, they were able to anticipate what the customer needed next, and they sent coupons to the homes of these customers for what they needed. I don't know if anybody has had that aha moment where all of a sudden you want something, you think about it, or let's say you decide, oh, I'm craving Indian food tonight, and you say it out loud, I'm craving Indian food, and then you Google Indian restaurants near me. And then you go on Instagram 2 seconds later and you start saying 50% off at the Indian restaurant down your street. This is big data. This is the power of big data analytics. My colleague Maiwa is going to send a link in the chat box. It's a case study of how Target uses big data analytics. I think it's a powerful example. It was in, I think it was, the article was written in about 2012 by Forbes magazine, but still very relevant today. And if I can argue, even more relevant today. So, excuse me, what exactly is big data? Data is defined as quantities, characteristics, or symbols. Big data is defined as data that is too large or complex to be dealt with by traditional data processing software. The 5 V's of big data, velocity, volume, value, variety, and veracity, are the 5 main and innate characteristics of big data. Data is not big data unless it has these 5 characteristics. Knowing the 5 V's allows data analysts to derive value from their data, while also allowing the analyst's organization to be more customer-centric. So let's talk about the 5 V's very quickly. Number 1 is volume. Volume refers to the amount of data that exists. If the volume of data is large, it is considered big data. Now, large is relative. So what we go as a rule of thumb is large is data in the millions. Velocity. Velocity is how quickly data is generated and how quickly that data moves. So data could flow from sources such as machines, networks, smartphones, social devices, machines such as your wearable devices. So for people who wear like Fitbits or Apple Watches, data flows from such. Variety, it refers to the diversity of your data set. So we're not just collecting data on people's personal information. We have personal information, we have what they purchase, payment information, and the likes. Variety, the concern with variety is that, or the challenge when analyzing big data because of variety, is that your data, most times it's not standardized as it's collected from various places. So your data could be unstructured, it could be semi-structured, or in some cases, it could be structured, or you could have a combination of all 3. Perfect. Veracity is the quality and the accuracy of your data. So gathered data should not have missing pieces. It should not be inaccurate. It should really provide a real valuable insight. Veracity overall refers to the level of trust you have in the data collected. And finally, value. Value refers to how valuable that data is. How can that data actually lead to business insights? A lot of times we collect data that or we have data for data's sake. There's really no value in the data we collect. So big data analytics is the use of advanced analytic techniques against very large, diverse data sets that can be structured, semi-structured, unstructured, and they are from different sources and in different sizes. So although big data analysts and data scientists are working with data to solve a problem and to find signal in the noise. So the noise is your data set and signal would be the insights. There's an amazing book, by the way, on signal in the noise. I would also put that in the chat box. It's a great book for people who are very interested in data and how they can use data to really build to really gain business insights or to even understand the power of data. So sorry, back to my point. There is a difference between big data analysts and data scientists. Big data analysts use data to solve current or future business problems by drawing insights from the past, while a data scientist uses more advanced machine and deep learning techniques to extract knowledge and insights. You can think of data analysts as more statistical and data scientists as more mathematical. So industries where big data is collected and used, insurance companies, they use big data to identify customers most at risk of canceling a plan or leaving the insurance company. Financial institutions as well, they use it to help make better investment decisions and ensure that they're getting consistent returns. Retailers, as I mentioned before, use big data to personalize in-store experience, to increase conversion rates through targeted promotions and predictive analytics, which was the example I mentioned earlier. Advertising companies, they use big data to discover new relationships, spot trends, spot patterns, and gain actionable insights that help them have a competitive advantage. So the example I gave on Indian food is a way of how big data is used in advertising, right? So organizations can use big data analytics systems and softwares to help make data-driven decisions that can improve their business outcomes. It's big data analytics is used to reduce cost. So it helps you find more efficient ways of doing business, increase profits. So by understanding what your customers like, what they need, you would attract them to buy more from your brand. So you're more likely to get more customers, and from the customers you already have, they're more likely to buy more from you. It enables you to really collect data on your market and your customers. It helps you make faster and better decisions. So the speed at which we get this data, right, and the ability to be able to analyze it very quickly, it helps you, make quicker decisions. And then customer satisfaction. Big data is great to gauge your customer satisfaction and to get ahead of problems. So if you already know that this is the demographic of the kinds of people, or these are the characteristics that make up people that churn from our business, it helps you get ahead and you know how to please those customers because you know the problems that they will potentially have in the future. So let's get to the best part. How do you analyze big data analysis? How do you analyze big data? So there are three main steps when it comes to big data analysis. The biggest difference is really within the data collation in comparison to, analyzing other types of data. So with primary data, you would do a survey, you would do a focus group, and you will analyze that data. With big data analysis, you actually have to combine data from multiple data sources. Remember, we talked about the 5 V's. So it has to be big, and it has to be from multiple data sources, and it has to be diverse in terms of the variables you have in there, the characteristics of the variables. So it's about data collation, data cleaning and preparation. So cleaning the data to ensure there's consistency. And then once it's cleaned, you can actually now run descriptive statistics, inferential statistics to help you make meaning from this data. So let's start with collation. So the bulk of big data generated actually comes from 3 sources: social data, so we can think of that as social media; machine data, we can think of that as wearables. So for example, Fitbits, Apple Watches, Google Home, any Internet of Things kind of technology. Even your cell phones, for example, right? Your behavior on your cell phones, and transactional data. So this is where the loyalty programs come into play, right? When you go into a store and you purchase something, being able to tie what you purchase to you. And even if you don't have a loyalty card, even when you purchase things at a store, that's still transactional data. It is a bit more difficult to tie that to you as an individual, but the store still has that transactional data. So examples, which I already started talking about, of social machine and transactional data will be your company loyalty programs, transactions from stores, from utilities that you have in your home, from telecommunication companies, behaviors on company websites, behaviors on third-party websites. I think we're almost all familiar of cookies, and this is where cookies play a role, your behavior on third-party websites, your behavior on your social media pages. Yes, it can be extracted. The things you sign up for, the things you register for, such as newsletters, contests, promotions, your phones and devices, such as your laptops, your tablets, your tracking watches, as I mentioned, Google Home, any Internet of Things device, any device you have that can be connected to the internet is able to extract data. So what happens is that we collect all of this data, we combine them. Some of this data comes structured. So for example, you could have more, how many steps did you take today? Have all of that in numbers. So on day 1, 5,000 steps, day 2, 10,000, and so on. And it can be unstructured. It can come in the form of numeric data. It can come in the form of more string data, so more text. You will have all of that diversity in your data, and that's very good. It is a lot more work when it comes to analysis, but it is great. So the next step is actually cleaning this data and preparing this data. So like any type of data, big data needs to be cleaned, even more so because of the diversity, as I mentioned, and it needs to be prepared for analysis. So you need to read through the data, try and remove any extraneous data or outliers, missing values, look out for missing values, arrange your data in a standardized pattern, private and sensitive information. Of course, we are all privacy aware, and we should be privacy secure working with data. Hiding private and sensitive data, you don't really need that data for your analysis, so just remove it. Even if you were able to get the data, you don't need it, you can remove it. So after the process of data cleaning and preparation, it's time to actually start validating your data, right? Checking if you have any errors. So you can run some analysis to check to see if you missed anything out, and then you clean again. Data preparation is really about cleaning and transforming your raw data before you actually start your analysis. In some cases, you will need to reformat your data and make corrections. The good thing about this is it is not a manual process. There are softwares and tools that help you clean and prepare your data before you actually analyze it. And the same software and tools help with analysis. And I will talk about them right now. So collated, clean, prepared data can be analyzed using the following analytical softwares. However, some of these softwares actually even help you with cleaning and preparing your data as well as analyzing your data. So the first is R programming. R programming helps you create syntax that can be used to analyze your data. The best thing about this is that as you keep adding more data into your data set, the syntax automatically just works with that data because you already have, the syntax is like codes, you already have the codes set up, so it just keeps analyzing it. So the thing about big data is that the setup is the hardest, well, I don't want to say the hardest, the most time-consuming part. The analysis is actually the most straightforward part. And maybe the hardest part would be actually deriving insights from that analyzed data. Lumify is a tool that aids in combining big data. So it combines the data from different sources. It helps you prepare it, clean it, analyze it, and visualize this data. So you're not just looking at numbers, you're looking at graphs and you're trying to make meaning from that. Apache Spark is an open source big data analytics tool. So open source is great because there's a lot of support. There's like an online community that can actually support you, and you guys are developing the code and the syntax together. Microsoft Azure provides a range of services that include computing, analytics, storage, and networking. So storage is very important because as you're collating this big data, you actually need somewhere to store this data. Remember, it's big. So our typical Excel file might not be able to handle all of this. So you actually need somewhere to store this data. And that's where Microsoft Azure is able to position itself, helping with storage and then the analytical part. Zoho Analytics is a data analytics software, helps you visualize as well, and also helps you understand, helps you find that signal in the data. So really helps you give you an in-depth understanding of what your data is showing. Xplenty, it helps you clean and transform this data. Splice Machine also helps you analyze your data, but they do it in batches. So if you have a data file of about 5 million entries, it would analyze the entries in batches and not necessarily the whole data file. Power BI, which most might have heard of, helps you visualize your data. So you put your data into Power BI and it's able to really help you see where the patterns are a bit clearer. And that's what Tableau does as well. It's also a visualization tool that helps you see the patterns clearer. And SQL, it helps you prepare your data and analyze your data. It puts it in tables and helps you see the numbers clearer. Okay, so analysis. So when analyzing data, the first step is to always have a plan. With big data analytics, it's difficult because a lot of times you don't even know what is in there, but you need to go in there and have a plan. And I think this is where, sorry, just want to remember what that tool is, not Zoho. The one who does in batches, Splice. I think this is where Splice works really well. Splice is able to look at your data in batches and be able to show you, okay, these are some patterns that we found. So with that, you can develop an analysis plan and figure out what exactly you're trying to analyze. Then take note of the structure of your data, right? And the variable type. So string variables are usually for text, so verbatims, words, while numerical variables are usually used for numbers, digits, or numerical variable. And then you can now figure out what kind of analysis you want to do. There are basic analyses you can do where you want to see the frequency, or you want to see how often one variable is showing. So that's frequencies. You just try to analyze the variables. So I can give you a very basic example. If you wanted to know how many people in your data set are in your so let's use Target, for example. So we have a list of all the women registered in our baby registry, and we want to know what trimester each of the women is in and how many of them are in each trimester. That's a frequency, right? So it will be trimester 1, 2, or 3. We run a frequency straight to the point. If we wanted to know, so we have the ages of every woman in our registry, and we wanted to know what the average age is of women in our baby registry. We run a mean, very simple. So it's just one variable that we want to do an analysis for, okay? If we wanted to see the relationship between two variables, so we wanted to see the relationship between age and let's say, okay, we wanted to see the relationship between age and what else could it be? Okay, age and maybe income, right? We can do correlations. So we want to see the relationship between their ages and their income. We do a correlation, relationship between two variables. And then the analysis goes on and on. A factor analysis is where you want to see, you want to be able to create groups. So right now, let's change it to the insurance company. We want to see what percentage of our participants or what percentage of our users who have life insurance with us or health insurance with us, what percentage of them will renew with us next year. And what percentage would not. So we know that so we can predict what percentage will renew with us and what percentage will not renew with us based on the characteristics of those who have not renewed with us in the past. So let's say we find out that people are less likely to purchase private health insurance if they don't have a job. So if someone, if you don't have a job, you're less likely to renew with us next year. We also found from our past data that people are less likely to purchase health insurance from us if they're within a certain age group. So let's say the younger demographic. So if you are within that age group, we know that you purchasing health insurance could have been an anomaly. So you're less likely to purchase from us. And the good thing about this is that you can actually have those buckets of people and reach out to them and understand their satisfaction levels and see what else you can do to get them to purchase next time. Or you can provide them with promotions or discounts to get them to kind of motivate them to purchase with you next time. We also have correspondence analysis and cluster analysis. So factor, correspondence, and cluster analysis are the same type of analysis. The differences are the types of variables you have. So is it a numerical variable? Is it verbatims? And are you using categories or is it scale? So a categorical variable, as I mentioned before, would be where the response from your participants can fit into categories, they can fit into buckets. And a scale variable is when it goes from 0 to infinity. For example, what is your height, right? You could be 5'2", 5'3", 5'4", 5'5", 5'6", 5'6.5". You can go from 0 to infinity. So those three types of analyses are used to create groups, but it depends on the type of variable you have. And then of course, regression analysis and logit regression. Regression analysis and logit regression are great to be able to see the relationship between variables and to be able to predict and do some forecasting to see what could happen in the future. Okay, and then visualization. So I just thought, just to note that we'll be sharing these documents with you, so you can always go back to them as you're actually doing an analysis, because I think that's the best way to absorb content. But we wanted to share with you this chart that kind of shows the best way to visualize your data, to be able to understand what you're doing. Because a lot of times you have the data, the issue is actually how the data is visualized before you can actually sit down and figure out insights. So if you have the best visualization, it's easier to derive the insights. So if you wanted to do a comparison between two variables or more than two variables, the top half are the type of charts that you can use. Even when you're using a visualization tool like Power BI or Tableau, you still need to know what type of chart to choose. So these softwares, unfortunately, do not chart things based on the type of variable. You have to decide what charts to use. So it's very important to understand charts that help you see comparisons, relationships, distributions, and compositions well. Relationships, when you want to look at the relationship between two variables, so you do a correlation analysis, and you want to see the relationship between two variables, scatter charts are really good. And you can draw a line in the scatter chart. That makes it a different analysis, a regression analysis, because you're trying to see how close each of the responses are to the line. But a scatter chart is very good for you to be able to see if things are going upwards, if they're going downwards, if there's no pattern at all in the data. No pattern at all, there's most likely no relationship between the two variables you're testing. So it's very good to know what charts to use, especially even though you will be using data visualization tools. Okay, and I just wanted to talk a little bit more about data mining. So I mentioned that the first step is to actually collate your data. And I mentioned that data is from three main sources. I mentioned social data, machine data, and transactional data. But a lot of times companies might not have transactional data. Most times comes directly to you. You have that data, but a lot of times you might not have transactional data. or for the research question or the business question you have, you need social data to be able to answer that question. And I think almost everyone, no one owns a social media site. So you don't have easy access to that data. So how do we get social data, for example? There's a data mining software called Rapid Miner, RIPIDMINER. That's a really strong tool to be able to extract data, social data especially. And then when you get this data, you need to figure out, how do I store this data? Because as I mentioned, Excel is just not going to cut it. Your system is going to keep crashing. Excel is going to keep crashing. So you need a tool, a system or a tool that can store this data for you as you're collecting more data or as you're trying to figure out what analysis you want to do. So for data storage, I mentioned Microsoft Azure was good for data storage, but there's also Apache Hadoop. So APACHE HADOOP, and there's also MongoDB. So I'll leave the floor open for anyone who knows any more data mining and data storage tools that you can share with us. The good thing about this big data subset is that things are always changing. Technologies that we use with data analysis, data collation, data mining, data storage, all of these tools and software that we use are always being updated. They're always being changing. They're always changing. And it's always good to be part of a community so you can stay up to date on what is happening with the tools and the software. The process pretty much stays the same, but what differentiates you or your insights from another company's insights will really be how you're extracting the meaning from that data. So I will leave it up to questions now. I think there's some there's something going on in the chat box because it keeps popping up for me. So I'll leave it up to questions now. And then afterwards, I think if anybody would like, as I mentioned earlier, we can work through a few case studies where a few people in the audience, you can tell us the type of data you collect, and we can brainstorm and talk through some of the analysis you can do or some of the business insights you can derive from that data. So Maiwa, if you want, you can read to us any questions if we have any, and then we can answer it and move on to the last step. Thank you.